For this question, we're told that for girls at the age of 3 years and 0 months, the second percentile for this height is 87.4%. So if I was to draw this as a normal distribution, so it would look like this, what it's saying is that this area here is 2%, and that this value here on the x-axis is 87.4. Okay, I'll just put the mean line down, and that the 98th percentile, which is up here, which means this area here is 2%, is 102.6, 102.6. So what they're asking is that, assuming that the distribution is normal, calculate the mean and the standard deviation for girls' height at this particular time. So what's really important here is that if these two numbers at either end here, so either if this percentile down here was different from this percentile up here, we would be doing a totally different methodology to solve this problem. But because they're both the same, and because we know that the graph in its entirety is normally distributed, that means it's symmetrical, we know that this area here is 48%. Okay, and this area here is also 48%. So therefore the total area in the middle here is 96%. Okay, and that therefore the mean has to be halfway between this value here, 87.4, and this value here, 102.6. So what I would do here is do a quick calculation to find the mean, because I know it's halfway between these two, because these two values are the same. So I would go 102.6 minus 87.4, and then divide that by 2, and then add that to, or subtract from one of those two values. And what that means is that, and then plus, I don't know, I'll go 87.4. I'll just go back and clean that up. Hang on. So that equals, and then I'd go plus 87.4. That equals 95. What that tells me is that the mean is equal to 95. Now I've got to work out the standard deviation. And this is where the Z formula comes into play. X minus the mean over the standard deviation. We know what X is. X can either be the 102.6 or the 87.4. We know what the mean is. That's 95. We can find Z by normalizing the normal distribution curve. And the way we do this is that we set up your calculator to the inverse normal. And because this is symmetrical, we can do this as a central tail, and we can say, right, our area is 96, but if we leave our mean equal to 0 and our standard deviation equal to 1, we normalize the normal distribution to give us the Z value. And you need to know this process when you're working on questions where you don't know either the standard deviation or the mean. So let's check out the calculation process of how to do this. So we go from the main menu to stat screen, we press normal and then inverse, and you'll notice here that it's currently set to the left tail. We want to change that to the central because we're dealing with the central area of the curve. We change our area to 96, and we're going to leave the standard deviation and the mean as 0 because that's how we normalize the curve. And you'll notice here it gives us two values. The negative 2.0537 is the Z value for the lower percentile, so the 87.4, and we can write that down. We can say when x1 equals 87.4, therefore the Z value is equal to negative 2.0537. And you always know that the left tail scores, or anything to the left of the mean, will always have a negative Z value. When x2, which is equal to 102.6, therefore z equals 2.0537. Now these two here are basically the same, apart from one being positive and one negative, is because they are symmetrical in terms of one is the bottom 2%, one is the top 2%. You don't need to write all that down, but you just need to be aware of that. So we need to take one of these, doesn't matter which one, because they'll both get the same answer, to figure out what the standard deviation is. I'll just take the top one because it's easier. The positive one. So I would say, well, I know my z-score is 2.0537 is equal to, so we're using this formula here, and I've just done the z, equals x, which is our value, 102.6, minus our mean, which we calculated is 95, and that's all over the standard deviation, which we don't know. Now in this situation here, we can just the algebra of it, and you can just remember, you can swap these two around. The algebra is that you would move the standard deviation up here, and then you would divide by 2.0537 to put it back on the fraction. So we're ending up that the standard deviation is therefore equal to 102.6 minus 95 divided by 2.0537. So therefore, the standard deviation is equal to 3.7. It's actually 3.700 or something, but that's your standard deviation. Okay, and that is your answer. So we've worked out our mean, which is up here, 95 kilograms, and that this here is 3.7. What you need to do is clearly show how you got the mean, and so you need to write a few sentences there. So something along the lines of, as the normal distribution curve is symmetrical and x1 and x2 are both at the 2% of either tail, then the mean is in the center. Or something like that. Something that clearly shows how you got to that. And then if you can get all of that, you've got yourself a T.